gas. So we have something called changes of state. Solids, liquids, and gases are called states of matter. A change from a solid to a liquid is known as melting. So if you want to melt an object, you are converting that object from a solid to a liquid. A change from a liquid to a gas is called evaporation. Okay, so we're looking at the liquid evaporating. So think about a puddle of water that's been left over from a rainfall, and that puddle ultimately, with the heat and the temperature around it, will cause that water to evaporate. Okay, and sometimes evaporation is known as vaporization. A change from a gas to a liquid is called condensation. So all of a sudden you might see moisture developing on the your inner windows, right? So what happens is the temperature that's outside is probably cool. The temperature inside has gotten warmer, and so what's happening is the water that is in the vapor form, pretty much in your surroundings, is now condensing. So it's with the window. So what's happening is the temperature outside is kind of a little bit cooler, and eventually you'll see the particles of water kind of going back from its gas state down to its liquid state, condensing onto the window itself. A liquid is a solid that is freezing. So if we want to convert a liquid to a solid, we freeze it. Okay, the state in which we kind of bring back the particles closer together and form a definite shape is known as freezing. We have the possibility of a solid going directly straight to a gas without the middleman being the liquid. Okay, and that's called sublimation. Okay, the opposite to sublimation, going from a gas directly down to a solid, is known as deposition. Okay, so see, these are a couple of key terms you're going to need to know for this chapter. The temperature at which a solid turns into a liquid is called a melting point. The melting point of water, we know, is at 0 degrees. So even though we think, well, doesn't it freeze also at that same point? And we're going to kind of address that in just a second. Okay, and that's here with the freezing point. So the reverse of a melting point is known as a freezing point. So when we melt something, we can refreeze it. Whatever the temperature is to melt something is also the temperature in which we will use to freeze it back, if we ever needed to freeze it back. So if we wanted to melt water, we want to make sure that the temperature is around 0. And then ultimately, as the temperature increases from 0, we're going to have the liquid. But we're going to look at a graph that kind of demonstrates melting and freezing point. So the melting point and the freezing point are always the same temperature. Okay, so even though it seems kind of hard to comprehend, I'm going, well, at 0 degrees, are we going to get ice? Are we going to get water? You know, what are we going to get? And I'll explain that in just a second. The temperature at which a liquid turns into a gas is called the boiling point. So the temperature in which all of a sudden, you're boiling water, and that water eventually evaporates into the gas form of water. Okay, it means that the water has reached what we call its boiling point. The boiling point is the same temperature as the condensation point. Boiling point of water is at 100 degrees Celsius. So at 100 degrees Celsius, water will evaporate into its gas form. So here we have our little graph. Okay, so what's happening is we've got ice. Okay, let's compare this to ice. So regular H2O. So what we've got here is we've got the temperature. So we know that the melting point, this is 0 degrees. So we know that the temperature here is representing a number that is lower than 0, less than 0, so in the negatives. So it's cold. So what's happening is we're still in that solid phase. And what we're doing is we're going to continue to add heat. And we're going to add heat to that piece of ice cube. And ultimately, it's going to start to melt. Now, it doesn't all melt right away, right? And then we could try to increase the temperature, but the temperature is not going to increase. So the temperature at this point doesn't change. So at this point, once we've reached this point, okay, in time, all the extra heat that we're adding to that ice cube is actually being used to try to overcome the forces that are holding that solid, that piece of ice, together and trying to break it apart. Okay, so it's holding the bonds together, okay, between one water molecule and the other water molecule, okay, between the particles, as it's turning that ice cube into a liquid. So we're looking at the whole ice cube ultimately melting and then forming, let's say, the water. And so once it's completely been melted, then the temperature of the liquid will start to increase. So as the temperature of the liquid, as it's absorbing all that heat, okay, it's increasing the temperature, and ultimately it will do the same at this plateau. So this is the plateau called the boiling point. And of course, not all the liquid will evaporate right away. So most of it will, some of it is going to evaporate, continue to evaporate, and eventually we'll have none of it left. Once we have none of it left, then we'll have this temperature increase in the gas. And this all occurs as time ticks away. Okay, so remember that we've got the melting point or freezing point if we're going in the opposite direction, and our boiling point or condensation point if we're going in the opposite direction.